Okay, so in this video, we have just finished section 3.1, which talks about measures of central tendency, or the middle of the data. So how do we figure out what is average? We have mean, median, mode, and we've started talking a little bit about ways that we might talk about some spread of the data, where we talked about what the mid-range is. Actually, that's not true. The mid-range is another measure of central tendency. So we haven't talked about any measures of variation or how the data are spread out. Sometimes people use the word dispersion for this. I tend to use the word spread. So what is the spread of the data? And these different measures of variation are things that we're going to use to describe whether the data clusters are right around the mean, or if the data is spread evenly out throughout the distribution. So I'll explain what I mean by that with some examples. So I have two brands of outdoor paint tested to see how long they last before fading. Here's the results listed below. So we have one brand of paint that only lasted 10 months before it started to fade, and up to 60 months before it started to fade. So I don't know what's going on with this brand of paint. Seems to not be a very reliable brand of paint, or maybe this was painted on a house in the desert, and it started fading right away, and this was painted in a house, I don't know, on the North Pole where there's no sun. But you can see that there's a lot more variation in brand A than there is in brand B. So that's, what can you tell about this data? It's a lot more spread out, right? If we are looking at this data, like this goes from 10 all the way up to 60, and this one only goes from 25 up to 45. So this data has a lot more spread. It has a lot more variation. It has a lot more dispersion. So those words that I just talked about. So more spread for brand A. So for mean, median, and mode, let's go ahead and compute the mean. So I have there's the mean of brand A. And now let's do the mean of brand B. So 35. So for both of these data sets, we have the same mean, but there's clearly something pretty different about the data, and that is that they're more spread out. For the median, we're going to look for there's 6 data values, so we'll look for the data point that is halfway between the two. So we go from 10, 20, 30, 40, 50, 60. So we'll get rid of those two. These are our 3 middle, is 20 and 30. So the median for an even number of data points is the average of the 2 in the middle. So here our median is 25. And brand B, let's look at highest. 1, 2, 3. I'm going to get rid of the 2 highest and get rid of the 2 lowest, and the 2 that are left will be my 2 that I average for the median. So I have 45 and 40 as my 2 highest. 25 and 20 is my 2 lowest, and I'm left with the 2 35s. So is also 35. And the mode is the most common value. This doesn't have a mode. And this has 35 twice. So the mode of this data is 35. The range for each brand of paint is the distance from the lowest value up to the highest value. So for this brand of paint, we have the range is 60 minus 10. So that equals 50. And for this brand of paint, our range goes from 25 up to 45. So 45 minus 25 is 20. So we have a much smaller range here, and that's what we already said, is that there's more spread in brand A. There's a larger range for brand A. So the range is kind of our first measure of variation. We have more spread here than we do here. It's a pretty crude measure. We're going to get a lot better with the methods in this section. So for brand A, what is the average distance of the samples for the mean? And I put this question in here because I want to start thinking about some better ways to talk about the average, to talk about the spread of this data. And one way to talk about that is to use the distance away from the mean. So here's what I mean by that. The distance away from the mean of this first one is 35, which is the mean, minus 10. So this distance is about 25. 25 clicks away. And let's go ahead and make this a negative number to show that it's 25 below 35. So it's a kind of a negative distance away from the mean. If we plotted these up on a number line, 10 is to the left of 35. 60 is 25 above 10. So that would be about 25. 50 is about 15 above 35. 30 is negative 5 away. 40 is positive 5 away. And 20 is negative 15 away. So a reasonable thing to do might be to say, well, in order to get the spread, let's just get a number that is the average of all of these distances that we are away from the mean. So let's average together all of these numbers and take the average of all of these numbers and compute that average. But if you see, when we do this, we're going to add these numbers together. Well, 25 and negative 25, they're just going to cancel. So that's going to give us 0. 15 and negative 15, that's just going to cancel. 5 and negative 5, that's just going to cancel. So if we do this, actually the average distance away of the samples from the mean for brand A is 0. Well, that's not very useful. So this isn't what we do when we're trying to get an idea about the average, the range of the spread of some data. We need to do something to make all of these numbers positive. And then if we had all these numbers be positive numbers and we added them together, then we would have some sort of single number that could tell us about how far on average away the data are from their mean, which gives us a good idea of how spread out the data are. So you probably have immediately gone to, well, let's just take the absolute value of all these numbers. So let's figure out, this would be 25 plus 25, which is 50. That's actually not what we do. Instead of doing that, we use something called variance. So the variance is another summation notation, and we have, again, the Greek symbol goes with the population, and the regular old letter goes with the sample. But other than the Greek symbol and the population, we're calling these things the same thing. So we've previously called mu the population mean, and x with a bar over it, the sample mean. And in here, sometimes this is written as a capital N, sometimes it's written as a lowercase n, is the number of observations. And this right here is our individual observations. So in your book, they'll put sometimes a little I down there to indicate that this is something that we're going to sum. So this is all of the individual observations. So let's do an example with this equation to figure out how it works. So here's the equation, and this is actually, I'll come back to that when we're done. So this is the thing that we are going to use to figure out the distance from the mean on average. And so what we did in the previous example here, if I can find it, is we said, what's the distance from the mean? And in this example, we're saying, what's the distance from the mean? That's the mean, the individual value, 10, minus the mean, minus 35. Instead of taking the absolute value of that number, we're going to square it, because the square of any number is also a positive number. So we talked about trying to take the absolute value of our negative numbers. The way that we really deal with that is with variance and also with standard deviation, which is coming up, is not by taking the absolute value of this number, but by squaring this number. Okay, so let's find the variance for a brand A paint. And here is our equation, which says that S squared is the sum of X, the individual X's, minus the average X squared, divided by N minus 1. So let's just plug in the numbers that we have here, that we found in the previous example, that the mean here is 35 and the number of samples was 6. So let's go that S squared is the sum of X sub I minus 35 squared divided by 5. Okay, so the first thing that I want to do is add up what all of these individual values are. So I'm going to create another column here that is xi minus 35 squared. And then when I get down to the bottom, I'm going to add up all those numbers. So my summation notation is that I'm going to do this one for the 10, plus this one for the 60, plus this one for the 50. We're going to get all of those numbers, and then we're going to add them all up in the end. And whatever that sum is the value in this summation notation. And once we get all of those, we'll divide it by 5. So, 10 minus 35, don't forget your parentheses, squared. I like to use my calculator a little bit more like a computer, so I don't have to retype all these numbers. I'm going to go store. So I'm going to push this button, STO, store, and hit alpha, and then A. So the little green letter underneath that is an A. And now my computer knows that if I type A, that the number 625 is in there. Just a little shorthand that's going to save me typing 625 or potentially making a mistake in typing 625. So this one is 625. The next one is 60. So we're going to go 60 minus 35 squared. I'll store that as B. So there's 625. 50 is 50 minus 35 squared. C. 30 minus 25. Oops, I started doing 25 here. It didn't matter for D, but it is going to matter for E. And let's just check and make sure that this works from what we had previously found for brand A. So these first two numbers should be 25 squared, and they are. The next number should be 15 squared, and it is. 5 squared, 5 squared, and I wrote that one wrong. My calculator gave me a 225, but I didn't write it as a 225. Okay, so in the end, I'm going to find the sum of all of these, the numerator of my formula, by adding all these numbers together. You can type them as numbers, but since I put them in as letters, I'm going to go A plus B plus C plus D, E, 1750. So that's the numerator. So we have that S squared is 1750 divided by 5. And that's what we got for that number. is 350. Okay. So that's our variance. And it's in the unit of something squared. So that's the variance, and that's how you use that formula. I'm going to leave computing the variance for brand B paint to you. So I'll have you do the exact same thing, but compute the variance of the brand B paint. We don't often talk about the variance. What would be more useful is a number that's not something that's sort of like the, this is kind of like the distance that this thing is from the average squared, which is not a super useful number. What would be a more useful number would be something that's more like the average of 25 and 5, the average of all of these distances. So if we could think about maybe this is kind of like the average of all these numbers squared. So a more useful measure of the spread of this data isn't this number, which is kind of like the spread of this data squared. But if we could instead take the square root of that number. And that's what we do when we take the standard deviation. So you've probably heard of the standard deviation before. And there's a formula for the standard deviation. The standard deviation of the population is the square root of the variance of the population. So this formula here is exactly the same formula, only I've added a square root. The standard deviation, and this shouldn't say variance, that should say standard deviation. The standard deviation of the sample is the square root of the variance. Make sure that my notes actually say what I need them to say. The standard deviation of this population is the square root of the variance. The standard deviation of the sample is the square root of the variance. So returning to our formulation here, I have that S squared is 350. So the standard deviation for brand A is the square root of 350, which is 18.7. Okay, and I'm going to leave finding the standard deviation for the brand B paint to you to do. And that is actually all that I want to do today.